Today we are going to look at trigonometric identities. An identity is an equation which is true for all values of the variables involved. Let us look at a right angled triangle, right angled at B. Let angle C be called theta. Now side AB would be my perpendicular, side BC would be my base, and side AC would be the hypotenuse. Recall that the perpendicular is the side opposite angle theta and base is the side adjacent to angle theta. Applying the Pythagoras theorem, we know that AB square plus BC square equals AC square. Dividing this equation by AC square and substituting the values in terms of PB and H, we get sin square theta plus cos square theta equals 1. This is the first trigonometric identity. Let us write down the equation for Pythagoras theorem again. Now this time let us divide both sides of the equation by BC square and substitute the values for P, B and H. So we get tan square theta plus 1 equals sec square theta. Once again, let us divide the Pythagoras theorem by AB square. Upon substituting and simplifying, we get 1 plus cot square theta equals cosec square theta. Now these are our three trigonometric identities. These are true for all values of theta. Let us look at a few problems. Express the ratios cos A, tan A and sec A in terms of sin A. Let us consider cos A first. Now we have to express it in terms of sin A. We know one identity that has sin A and cos A both. So let us write sin square A plus cos square A equals 1, which is the first trigonometric identity that we learned. Let us rearrange the terms and take square root on both sides. We get cos A equals square root of 1 minus sin square A. Next we have to find tan A in terms of sin A. Let us simplify tan A and write that as sin A upon cos A. We can substitute the value of cos A in terms of sin A. Lastly, we have to find secant A in terms of sin A. Now we know secant A is the reciprocal of cos A. Once again, let us substitute the value for cos A in terms of sin A. And we are done. Let us look at another problem. Evaluate sin square 63 degrees plus sin square 27 degrees divided by cos square 17 degrees plus cos square 73 degrees. Now here we are looking at squared terms. We know that squared terms appear in our trigonometric identities. Now the first identity that we learned, which is sin square theta plus cos square theta equals 1, mentions both sin and cos. Now we do not know the values of sin 63, sin 27, cos 17 or cos 73. However, we can check whether 63 and 27 add up to make a pair of complementary angles. Similarly, we can check if 17 and 73 add up to 90 degrees. Yes, they do. So we could write the numerator as sin square 63 degrees plus cos square 90 minus 27 degrees. Similarly, in the denominator, we can change one of the terms to its complement. Now we get an identity in the numerator as well as in the denominator. So sin square 63 plus cos square 63 would add up to 1. Similarly, sin square 73 plus cos square 73 would add up to 1. So the expression is equal to 1. Let us look at another problem. Prove that tan theta divided by 1 minus cot theta plus cot theta divided by 1 minus tan theta equals 1 plus secant theta times cosecant theta. Now this problem looks complicated, but there are a few interesting things to note. On the left hand side, the terms mentioned are tan theta and cot theta, whereas the terms on the right hand side mentioned are secant theta and cosecant theta. Now note that secant theta and cosecant theta are the reciprocals of sine and cos. which means that we have to change our terms in terms of sine theta and cos theta. So let us express our left hand side in terms of sine theta and cos theta and simplify. We see that the denominators are similar. Let us take an LCM. But the problem is that the numerator becomes complicated. We get sine cube theta minus cos cube theta. Do you recall any algebraic identities similar to a cube minus b cube? Yes, it gives me a minus b times a square plus ab plus b square. Please note that in the denominator, we have a term called sine theta minus cos theta, which is similar to a minus b. This shall help us in simplification. Dividing both numerator and denominator by sine theta minus cos theta, we see that the numerator becomes sine square theta plus sine theta times cos theta plus cos square theta. Once again, recall the first trigonometric identity that we learned, where sine square theta plus cos square theta add up to 1. So simplifying further, we get one of the terms as 1 upon sine theta cos theta and the other term as 1, which leads us to cosec theta times sec theta plus 1, which is the same as the identity given in the question.